Hey, this is Mr. A, and I'm going to go through this quiz that we had on describing motion. I'm going to do it pretty quick, so if you have any questions, if something's not clear, please just go ahead and stop the video, rewind it, do what you need to do, or you can ask me, that's fine, but I just want to go through and answer these. So the first question is just about units, and I've asked you what are the units for distance, and the units for distance are, of course, meters. The next question is about distance and displacement. We talked a lot about that in class. And this one, I want to know what the distance is. So if he runs 200 meters in one direction and 100 meters in the next direction, we're just simply going to add up those. So 200 plus 100 is equal to 300 meters. Now, if this was displacement, that would be a different question. So you'd have to figure out how far he was from where he started. The speed equation, you remember that speed is equal to distance divided by time. So speed can be calculated by dividing distance by time, right? So that's answer A. You need to know the difference between average speed and instantaneous speed. So the speed for an entire trip, so the average speed is the entire distance divided by the entire time. That is average speed. Average. You need to know the difference between speed and velocity. Two cars are traveling 72 kilometers per hour. Sounds like they're traveling the same speed, but one is going northeast and the other is going south. So they're going different directions. They have different velocities. The two cars have the same. I ask you what they have the same of. They have the same speed. Okay, let's push this up. Okay, the next are word problems here. Okay, we're going to do some word problems calculating speed. So if I want to calculate the speed of a fastball, speed again is equal to distance divided by time. I am given that the distance from the pitcher's mound to home plate is 18 meters, and 0.43 seconds is the time it takes for the ball to travel. So it's 18 divided by 0.43, 18 divided by 0.43, and the answer is equal to 41.86, or let's see, with sig figs, a couple of looks like two sig figs there, 42 would be my answer. 42 what? 42 meters per second would be the answer for that. This time I'm asking for how much time it's going to take. So time, here's our triangle. We need to have our triangle handy if we're going to calculate this. Put our finger over time, and time is equal to distance over speed. Time is equal to distance over speed. So if the distance is 18 meters away and the speed is 7 meters per second, then 18 divided by 7 is equal to 2.57. Or with sig figs, oh gosh, there's only one sig fig here, so that's, I don't know, you can round that up to 2.6, or I suppose you can round that all the way up to 3, and I would still count that correct. 3 what? 3 seconds with the proper number of sig figs. The last problem, word problem for speed, is I'm going to calculate the what is the distance to the target if the bullet is traveling. Let's see, so distance is equal to speed times time is equal to the bullet is traveling at 600 meters per second, and it takes 0.1 second to get there. So 600 times 0.1 is equal to 60 meters is the distance. Okay, let me flip it over to page 2. On this graph, where is the object going a constant speed? Well, a constant speed is always where the line on a distance versus time graph is a constant slope. And that would be section B here. This is curvy, this is curvy. Now this is where the object isn't going anywhere. Is that a constant speed? Is a speed of 0 a constant speed? Well, I ended up having to accept that as an answer because I guess a speed of 0 is a constant speed, but what I was really looking for was region B. Now then, calculating speed from a distance versus time graph. And this one, I wanted to calculate the average speed. All you had to do to calculate the average speed for racer A is to figure out how far he went, what was the total distance he went in the total time. So the average speed is equal to the total distance divided by the total time is equal to 40 divided by 8, and I think if I remember right, that is 5 meters per second. Always put your units on there. That lets me know that you know exactly what you're doing. Which racer had the fastest? This one time I'm asking you for instantaneous speed. This racer had the steeper slope, so he had the faster instantaneous speed. Right? Now, I caution you, I could have had a racer who did this. He went really slow for a while, and then he had a burst of energy to finish the race. In this case, racer C would have a faster instantaneous speed because he had the steepest slope of all. But racer A won the race because he covered the distance in the shorter amount of time. So I don't know, I'm just kind of telling you different ways I could ask questions like this. I like this graph because I could say which racer had the fastest average speed and which racer had the fastest instantaneous speed. Those are two different questions, and two different racers would have been the answer to that. Okay, moving on, question number 12. Now we're moving on to the subject of acceleration. Acceleration, you remember, is the change in velocity over the change in time. So you divide the change in speed divided by the change in time. That would be answer A in this one. Positive versus negative acceleration. For this one, I wanted to know greater than. So positive acceleration, if I drew a little speed versus time graph right here, and I showed a line, means that your initial speed, one down here, how does that compare to your final speed? Well, your initial speed has to be less than your final speed for it to be positive acceleration. This is a line of positive acceleration. It's got a positive slope. This would be your final speed, and this would be your initial. All right, so your initial has to be less than your final has to be greater than your initial. Okay, these next three are acceleration word problems. So we are going to need our full-blown acceleration equation, which is acceleration is equal to Vf minus Vi divided by Tf minus Ti. And then you need to write in, you need to figure out what all these Tfs and Ti's are. Your, let's see, a downhill... I'm on the wrong problem here. Oops. Well, same equation, same problem. Acceleration word problem number 1. Let's do acceleration word problem number 1 before we do acceleration word problem number 2. But it's the same. It's the same equation here. So a skier starts from rest at the top of the hill. So her initial velocity is going to be 0. 10 seconds later, that's our difference in time, 10 seconds later, she's going 30 meters per second. So our final velocity is equal to 30 meters per second. So we have everything that we need here. I'm taking some shortcuts, yes I am. 30 divided by 10 is equal to 3, a positive 3. Maybe I shouldn't have gone so quickly. Let me let me slow down a little bit here, because on these problems we really need to figure out what our VFs and VIs and TFs and TIs are. So a downhill skier, she's going 30 meters per second initially. So our VI is equal to 30. Now then 5 seconds later, so our TF is equal to 5. After 5 seconds, she's going 40 meters per second, so our VF is equal to 40. Now, some students will ask me, well, what was my TI? Well, in a lot of these questions, you just assume that your initial time is 0, or your difference in time. Remember that this acceleration equation is your change in velocity over your change in time. So maybe a better way to think about it is that 5 seconds later, that was your change in time. So change in time was equal to 5 seconds, right? And we don't need a TI because we have our equation written like this. Well, this is our equation. This is all of the stuff that is known. So now we're going to calculate. So A is equal to our 40, which is your VF, minus your VI, which is your initial, and divided by your change in time, which is 5 seconds, which is equal to what? That is equal to 10 divided by 5, which is equal to 2. Gosh, I didn't put my units up here. I need to put my units down here. We're calculating acceleration, so this is meters per second squared. This up here is meters per second squared. Okay. All right, 3 and 2. These are positive accelerations. These next two are going to be a little bit different. Here, a downhill skier, she's going 40 miles, so her initial velocity, 40 meters per second. Her initial velocity is 40 meters per second. 20 seconds later, so delta T is equal to 20 seconds later, she is coming to a complete stop. So her final velocity is a complete stop of 0 meters per second. All right? Now, what is the skier's acceleration? Well, A is equal to VF minus VI over our change in time. Okay, and so VF now, you got to plug these numbers in right. VF is equal to 0 and VI is equal to 40 over our change in time, which is 20. 0 minus 40 is a minus 40 divided by 20. 40 over 20, negative 40 over 20 is a negative 2. If you left off that negative sign, you would have gotten it wrong. Negative 2 meters per second squared. Okay? And the last problem, gosh, this is probably the hardest part of the quiz right here. Okay, a race car is going 100 meters per second, so its initial velocity is equal to 100 meters per second. 2 seconds later, so our delta T is going to be equal to 2 seconds. It's going 80 meters per second. So our final velocity is equal to 80 meters per second. Plugging that in our equation, the final velocity was 80. The initial velocity was 100. Our change in time is equal to 2. So that's 80 minus 100 is a minus 20 over 2 is equal to negative 10 meters per second squared. You got to get these in the right order so that you know whether you've got a negative sign or not. Okay. Boy, that really bogged us down there. Okay. Let's look at this page. So now we're looking at speed versus time graphs, and I want to know what region does the line segment illustrate a constant speed? Well, this looks like increasing speed. This looks like decreasing speed. This looks like zero speed. I want to know where constant non-zero speed is, and that is in section B. All right. Now, we've got 4 questions that relate to this graph right here. So we are going to be calculating acceleration from a speed versus time graph. And the first question is calculate the acceleration between 0 and 2. Alright, so between 0 and 2, my initial time is equal to 0, my final time is equal to 2, my initial velocity, so my initial time, my initial velocity is equal to 0, and my final velocity is at my final time, so I go to my final time and I go up and it's equal to 30. Okay, so plugging these numbers in, acceleration is equal to my final velocity minus my initial velocity over my final time minus my initial time, which is 30 divided by 2, which is equal to 15 meters per second squared. So far so good with the first one. Okay, now the second one, between 2, my interval is between 2 and 4. So my initial time is equal to 2, my final time is equal to 4. My initial velocity, so I got to go to 2, and then I go up to find my velocity, so my initial velocity is equal to 30, and my final velocity, oh my gosh, at 4, it's also, my final velocity is 30. So if I go plug this into the acceleration equation, I get 30 minus 30 in the numerator divided by 4 minus 2, but that doesn't matter, my denominator, because my numerator is 0. So 0, well that makes sense. 0 acceleration because, look, I wasn't changing speed in that interval. Okay, so that one was kind of tricky. Let's move on to the next interval between 8 and 10. Okay, so my initial time, ti, is equal to 8, and my final time is equal to 10. And my initial velocity at 8 is equal to 20, so my initial velocity is equal to 20, and my final velocity at t equals 10 here is 0. So plugging this into the acceleration equation, I get 0 minus 20 divided by 10 minus 8. That's a negative 20 in the numerator and a 2 in the denominator. So that is minus 10, right? Meters per second squared. Gotta have that negative. Circle the answer. Let me know that you know what you're doing. And the last one here, gosh, this is a really hard part of the quiz too. Let's see. Between the interval of 4 and 6. Okay, so my initial time is equal to 4, and my final time is equal to 6, and my initial velocity, I go to 4, and that's 30. And my final velocity, can you see this on the page? Am I right? Yep. My final velocity at time is equal to 6 is equal to 20. Okay, so plugging this in my acceleration equation, I got 20 minus 30 divided by 6 minus 4, and that is going to be a negative 10 over a negative, sorry, not a negative 2. 6 minus 4 is not a negative 2. 6 minus 4 is just 2. And so that is equal to a minus 5 meters per second squared. Got to have that in mind. Circle your answer. Let me know you know what you're doing. Okay? And now, this looks like we're on the last problem because I did not grade these two because I didn't teach it to you. This one, these are a set of motion graphs, so I've got a set of motion graphs here for C, a set of motion graphs here, B motion graphs, and a set of motion graphs here. These all go together vertically, and I'm just asking you which ones, A, B, or C, apply to this situation where I have a ball rolling downhill. So my question to you is, when a ball rolls downhill, is it going to speed up, slow down, or stay the same speed? A ball rolling downhill picks up speed. So it's this one, and the speed versus time graph shows increasing speed, so the set of motion graphs that apply, that makes sense. We've got the ball is accelerating downward, and as the farther it goes, the faster it gets. So B is your correct answer for number 23. Okay, so that was the quiz gone over.